Today on the Perception and Action podcast, I'm joined by Elina, Nijmeijer, and Benjaminse from the University of Groningen in the Netherlands to talk about their interesting new work on implicit training to reduce injury risk in athletes. So it's time for a call to action. Hi, this is Rob Gray from Arizona State University. I've been on a now over 25-year journey as a researcher, professor, and high-performance consultant to understand how we acquire and adapt our perceptual motor skills. Welcome to the Perception and Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. Before we get to today's topic, I want to tell you about a couple extra things that might interest you if you're enjoying the podcast. First, my book, How We Learn to Move, A Revolution in the Way We Coach and Practice Sports Skills, is now available in audiobook format. You can find it on Audible or Amazon. Second, if you're interested in working directly with me, I currently have openings in my monthly mentorship program. This includes monthly Zoom meetings, either one-on-one or with your staff, analysis of your practice designs, and a monthly group discussion with coaches and instructors from a range of different sports. To find out more, please go to patreon.com/perceptionaction. Now on to the show. Okay, it's my pleasure today to be joined by Elina and Anna to talk mostly about their really interesting new paper on using video demonstrations and instructions for coaching, and maybe a little bit about some of the other exciting things they're working on. But to start off, I thought I would let them introduce themselves a little bit. Elina, welcome to the podcast. Can you tell us a little bit about yourself?
Yes, thank you, Rob. Yes, I'm Elina Nijmeijer, and I started my PhD 1 year ago at the University of Groningen in the Netherlands, mainly about motor learning and how we can use that for injury prevention in team sports.
Cool. And Anna, nice to welcome back. You've been on a couple of times before, I think, at least. Can you tell us a little bit about yourself? Remind everybody.
Yeah, thanks, Rob. It has been a pleasure, and thanks for inviting us again. Indeed, I'm an assistant professor at the Department of Human Movement Sciences at the University of Groningen in the Netherlands. And as Eline was saying, I'm mainly interested in doing motor learning research to help our athletes and coaches to prevent injuries as much as we can and to enhance performance.
Okay. Yeah. No, great. I know you work kind of both in the sports and rehab side of things, right? And yes, and that's a great department. If anyone wants to go and visit, that's a great place. So I want to talk about your paper that just came out in the Journal of Sports Science and Coaching on video instructions. You know, I get this asked a lot, especially the way we're kind of changing our thinking about how we coach and things using video and demonstration. What's the best way to use that? So, Anna, I'll start with you. Maybe could you tell us a little bit about the background, kind of motivation for this study?
We're during our research projects or in our research project, we're just trying to set up different projects to investigate how we can best help our athletes. We're trying out different types of mainly implicit motor learning techniques, so to say. And some projects are more focusing on verbal instructions or feedback. But as we learned from past studies, video instructions and feedback seems to be also really powerful for athletes to search their own optimal movement, so to say. So that's why we set up this project.
Okay, great. And Elina, maybe can you tell us a little bit about kind of what you found people have done before in this area and what your goal was with this study?
Yeah. What we know from studies is that video instruction is more and more a common tool also for trainers and coaches to use. However, we do not know what type of model or what type of level of the athletes, to imitate, works the best. So that was also one of the reasons for this project to see, can athletes imitate optimal movement patterns, but can they also imitate less optimal movement patterns? And if so, what are the implications of that?
Okay. So you're talking about a situation, where maybe I'm doing a jump landing or something, and you're going to show me a video, and ask me to just kind of we could do that movement myself. And when you kind of say optimal and suboptimal, what do you mean in that? Obviously, that's a key point in the.
Yeah, that's a good question. For this paper, we based it on biomechanical variables, and then the optimal ones are the less risky variables, so to say, for example, knee injuries. So we looked at the knee flexion angle, knee range of motion, vertical ground reaction force, and ab or adduction angles and moments. And based on that, we selected an optimal movement pattern, so with less risky variables, and a more risky pattern, and we call that the suboptimal movement execution.
Okay, so you're looking at like ground reaction forces and angles, and things that are potential causes for injury.
Exactly.
And so did you have? So in creating an optimal video, did you just have kind of tell a person to jump in a certain way, or did you find a kind of a one that you liked, or how did you?
Yeah. We really asked the coaches because these were young basketball players. They were talented and part of a talent center, so to say, selected for that center. Mm-hmm. And we asked the coaches because they see them almost every day. Okay, what's your most motor proficient player, so to say? Who do you think is, in terms of motor control, your best player? And that's, of course, that's also gut feeling. But I also want to trust the coaches that they have the experience with their athletes. So I trust on their judgment, so to say. And those athletes came to our lab. And then, we instructed the athletes, and because we also wanted to have a quick win, also sometimes with explicit instructions, please adopt this posture while performing this cutting maneuver. And, because we were videotaping them and we wanted to have them on the video in those optimal and suboptimal positions, so to say. And those were based on a paper from a Dempsey a while ago, in which the athletes adapted different movement postures, so to say, and movement skills. For example, foot turned in or foot turned out, or knee more extended or knee more flexed, and then they calculated angles and moments. Mm-hmm. So based on those different postures from the paper from Dempsey in 2007, back in 2007, Alistair Dempsey, we were like, okay, we have some postures which have less joint loads at the knee and more joint loads at the knee. So, and that's how we created those two examples.
Okay. So you had try doing a cut. So you were doing cutting maneuvers, and you had a person. I want you to run and plant with your foot out. You're turned out.
Exactly.
Yeah.
Yeah.
And
to
create the stimuli. Yeah.
To create the instruction video, so to say. Yeah.
Okay. And and I know what you mean when you're talking about that. Sometimes I ask the coaches, well, who's the best mover on your team?
Yeah.
And they usually can. They know. It's hard to put into words why, but
exactly
they know why. Yeah. So, Elina, so you made these videos, and then what were the groups kind of in your study, the design?
We used one group of athletes from the same team as the expert one. So the instruction videos were based on. They are around 15, 16 years old and are the talented basketball players of the north of the Netherlands.
Okay.
But it is important to say, I guess, that at least the subjects are from the same team as the expert was.
Mm-hmm. Okay. So, because I think we skipped over that. And there's a bunch, whether, when I want to teach you how to play basketball, and you're 15, should be showing you a video of LeBron James, or someone closer to your actual level, right? I think it's been a big debate, hasn't it? I think if I remember, there's evidence kind of for both, benefits of both, right? In observational learning. Yeah.
I think so. Yes. It's also just in not directly to immediate motor learning or something like that. It's also cool as an example to see such a player, such a famous player, and it may be motivating also. But if you really want to learn to play like him, like LeBron James, for example, maybe you should take it step by step and not expect your youth player to already be able to execute a skill like he's doing. So that's basically what this paper is about and what the results also show. Maybe if you want your athlete to become better, show a slightly better player to him so that it's doable for him. It's not demotivating because he may be if the expert is, so to say, too far away from the player, he's too good, then it may also be demotivating. There's no way I can do this.
Yeah, they don't know how to produce that pattern of movement themselves. Yeah, for sure. I think that's what you see. You're right. There's the benefits, but it can be hard to actually learn from it. Yeah. So you have basically, Elina, you had basically peers, the videos with your peers, people that are similar level to you. You showed them the video of the optimal cutting maneuver and the suboptimal. Did they see both? Was it within subjects kind of design?
Yeah, they have seen both. We counterbalance the conditions between the athletes.
Okay.
So they saw the expert video, for example, of the optimal condition, did 3 trials, saw the video again, did another 10 trials, and then we moved to the other condition and did the same for the other condition.
Okay.
And before that, we collected also 3 trials of their baseline, so without any instruction, without any video, just their normal movement execution.
Okay. And what were the instructions that went along? So they were watching the video of this cutting. What were the instructions that went along with that?
Well, not that specific.
Okay.
The only instruction was, look at the video and try to imitate this as good as possible.
Okay.
So we did not say anything about, was it good, was it bad, knee angles, nothing, just, try to replicate the whole movement. Yeah.
No, that's really interesting. I think because on the surface, it sounds like we started talking. It sounds like you're prescribing an exact technique, right? Because you're but that was used to create the videos, not to use to coach the athletes, right?
Yep.
I think that's a really interesting twist. Yeah. You just said watch this and do it. So it's more like you said, Anna. It's more implicit. Yeah.
Yeah, we need to be clear indeed, because it was also, I think, in the first review round, not clear also really. Before the study began, actually, we created the expert videos. And with creating the expert videos, we wanted them to perform the movement in a short time exactly how we wanted. So there we used some explicit instructions also, but the intervention was like Eline just said.
Okay. Just watching the video. And then you measured, so you did pre and post training. How was it kind of a short term where they would just watch the video a few times within a single session? Okay. Yeah. And you did pre and post cutting. And then I'm assuming you measured all the kind of the same things that you took and for, ground reaction force, all that kind of stuff.
Yeah. Actually the same variables as we used to create the expert. So knee flexion angle, knee flexion range of motion, moments in the frontal and sagittal plane also, and in vertical ground reaction force, like you said.
Okay.
And unfortunately, we did not have the time in this study to measure retention, for example, a week later. So that's a bummer for this study.
Yeah, I was going to ask about. Elina, can you tell us what did you find in terms of the main findings of the study?
Well, in general, I think we can say that it did not depend on the level of the video that they had to imitate, but it was more, as we already spoke of, about the gap between the initial level of the subjects and the expert level.
Okay.
So what we saw was that there was a big difference between the baseline level of the experts, baseline level of the subjects, and the optimal execution of the expert.
Okay.
And the results showed that the subjects were not able to close the gap or to reach the level of the expert.
Okay.
On the other hand, regarding the suboptimal execution, the subjects showed similar movement patterns in the suboptimal condition as the expert already did.
Okay.
So to conclude, it did not depend on the level of the video that they had to imitate, but it was more about the gap between their baseline level, so their initial level, and the level of the video.
Okay. So there wasn't some natural pull towards optimal moving, right? By just because it was just because they happened to start they started closer to suboptimal. I'm guessing the athletes you had, so it was probably easier for them to adjust to what they saw in those videos as opposed to the optimal. Is that kind of what you would? So it's more of the gap between what we're trying to get you to do than the
maybe the suboptimal one also looked maybe a little bit more strange because, for example, the tool was placed outwards instead of inwards. And I thought, okay, this is real different from what I'm doing during the baseline.
Okay.
Because we did not say anything about the difference between the baseline and the videos. So maybe that's also one of the reasons that we saw more differences regarding the suboptimal one.
Okay, so your kind of conclusion was the optimal video is a good idea, but you have to kind of, like you're saying, Anna, maybe stage it, so it's closer to where they're starting, and you're kind of progressing with the smaller changes. Yeah.
Yeah, more familiar, maybe also like Eline was saying, and maybe they were already thinking because they did not see themselves in this study.
Yeah.
Maybe they were already thinking, I'm already doing it like he's doing, like the expert is doing. So I don't need to change that much. Whereas with the suboptimal might indeed have looked kind of weird to the kids, and then they started trying to replicate that.
Yeah. Yeah, I was kind of wondering about that, like the information they had for making the change. Like, I think you deliberately didn't give them any, right? You want it because that's what these we do. Here, do this, and they don't know what this is. There's no specifics about what this is, right? You're not telling them, by this I mean bend your knee, turn your foot outward. You're hoping what they pick up from watching the video. Yeah.
Yeah.
In the end, maybe in these. The research on these kind of optimal movements in terms of injury, are there related like performance effects? So do you actually get faster in making the cutting movement if you use these optimal movements? Or is it more just injury kind of prevention?
Well, this study was more related to injury prevention. However, we controlled for the speed, so we did not want them to lower the speed too much, for example. Okay. So the performance needed to stay the same at a certain level. We verbally encouraged them to run as fast as they could. Of course, there's a kind of injury performance conflict at some point. There are some studies about that also, that more knee flexion takes more time. And in another jump landing study, we did show, luckily, that with the implicit instruction group, seeing an expert video also, and with external focus instructions, those two groups did improve their jump landing technique, so to say, but their jump height also stayed the same. So luckily, we do try to measure also performance outcome measures.
The problem I think is like trying to get someone to move differently for injury prevention. It's hard to motivate because injury prevention is a long-term goal with no direct consequence in the moment, especially for a young athlete. What do I care whether I'm going to have bad knees when I'm 30, when I'm 15, right? So I think Yeah, but I like to believe, I don't know if this is always, that injury risk and performance kind of go hand in hand a lot of the time, right? If I put too much force or break the chain, it makes me actually so slower and more chance of injury. I know that doesn't always work, but I like to think it does, because so if you can get people to, like, when you turn your foot this way, yes, it's going to prevent injury, but also if it makes me cut faster, that's going to give them much more motivation to adopt that new movement.
Yeah.
Right? Yeah.
Yeah.
So,
yeah, that's why because you were asking in the beginning, what kind of projects do you have going on? We just finished a project where we designed injury prevention routines together with soccer coaches, and here we really implement the exercises within routines that they are already doing.
Okay.
Agility, deceleration, acceleration. So here we're trying to coach the coaches also to not only look at performance outcome measures, so who has the ball first, or who did you make a goal at the end of the trial, the end of the task, but also please have a look at how the athletes make that agility maneuver within a routine that has a performance benefit. It's primarily designed for performance. And in that way, you kind of motivate, hopefully also coaches to, so to say, to have a win-win.
Yeah.
And to also have to look at injury prevention.
Yeah. No, I think so. It's like I said, it's a hard thing to motivate. It's the same reason, when we're young, we do lots of dumb things for our health in terms of off the field, right? We tend to be kind of, we don't think about those kind of things. Elina, I wonder, so if I'm right, the most, so these are, skilled basketball players. Most of them are moving fairly suboptimally in terms of, are closer to suboptimal than optimal. Is that fair to say in terms of what you found, or they have a lot of room for improvement in how they're moving in terms of injury risk, would you say?
Well, I will not say that they were closer to the suboptimal one already, but because the difference between their initial level and the expert suboptimal one was not that large or was small, it was easier, or maybe, it was easier to close that gap to go to the suboptimal one.
Okay.
And the suboptimal one is still a relatively good one, although it is not that good as the optimal one. So therefore we are using the words optimal and suboptimal and not positive and negative or worse and good. Because the suboptimal one is still a safe one, but not that safe as the optimal one.
Do you have I wonder, why were they closer to the suboptimal one? Is it just how they're coached, or is it more natural? I was wondering, is this kind of they've never taken this into account? Did you have kind of any thought about that?
Well, regarding the instruction was the same for the optimal one and the suboptimal one.
Okay.
And we also make some, looking at the videos itself afterwards, we saw some big differences in the foot placement and the knee angles, or was it knee extended or knee flexed? And maybe the subjects also saw the differences, but although they did not see themselves performing the exercise, they may thought, okay, I'm already at the level of the expert for the optimal one, because they were from the same team.
Right. They didn't.
And when they saw the suboptimal one, they said, okay, this is very strange regarding how I think I'm doing it.
You're right. That's a good point.
So that could be a reason. Yeah.
Yeah, that's a good point. Yeah, no, I think that's a really interesting study. I think, I think it adds to this kind of observational learning and right. And I like how you did it in a kind of I'm the more natural way of just showing people things and seeing what happens rather than instructing them. You mentioned a little bit about Anna. You mentioned a little bit about kind of what you're working on now. Elina, what's kind of next in your PhD, your research? Now that you're free to measure things out and not over Zoom or anything like that. Yeah.
Well, one of the projects that we are running right now is not only using the video instruction, but also video feedback. So we're trying to investigate how much the athletes can learn from seeing themselves performing the exercise.
Okay.
That was one of the things that we did not do in the current study, because we think that it can help them if they see, okay, this is how I'm doing it right now. This is how the expert or the example is doing it. How can I change my own movement execution to, close the gap?
Mm-hmm.
Or do they need verbal external cues or implicit cues, extra or plus, to change their movement execution? So basically, is video instruction enough, or do they also need video feedback or verbal feedback in addition to change their movement executions?
Yeah.
And not only in the lab, but we are also able to measure them on the field, so on the soccer pitch, with IMUs, so inertial measurement units, to see how they move over there, because that's the place where the injuries happen. Yeah. And most of the injuries will not occur in the standardized environment.
Yeah, I think that's a big challenging question, isn't it? The transfer from these kind of things. As soon as you put a ball in front of people, they suddenly move differently, right? Than all the things you've taught them in a lab and all the training you've done. So yeah, it's a big challenge. But yeah, I think I like that. Anna, you've done some work like that before, right? When you've you've done some where you kind of superimposed my movement onto an expert, or like put them together, and where you could show how I was moving relative to the model. Yeah. I think that's a really interesting idea. Mixing self-modeling and expert modeling, I think, is a really interesting idea. Yeah.
Yeah, and but still, that was also in a lab setting. And I think when you're asking what's next, that's really the transfer to the field. We just recently published a paper measuring agility in the lab and on the soccer pitch. So basically, movements are the same, but just the environment is different, which, the results showed that the kinematics was actually different. So the environment really does matter. And so there's also studies coming up where indeed with a ball, without a ball, but on the pitch, without defender. And
good.
Yeah, I think that. Yeah, the environmental influences or neurocognitive influences, how you want to name it, but that's really important to consider.
Yeah, I think that's a good first step, understanding why. We all know it does. It's different, but why? What about the environment makes it different? I think that's a great step we have to take, right? Instead of just hoping, things will stick. Yeah.
Exactly, and maybe some athletes do handle it better, of course, than other athletes, the environment. So we also want to kind of investigate in the incremental steps. Okay, what if you add a ball, or what if you add a ball and a defender, and then kind of see when the person starts to become at risk, so to say.
Yeah, what changes about
it? So yeah.
Well, that's great stuff. Yeah, really interesting work, and I'll keep an eye on you. Maybe I'll have you back on when you finish the rest of your studies. I'd love to hear about them. So thank you very much for joining me. Okay, that's it for today's episode. Remember, you can contact me at robgray@asu.edu or follow me on Twitter at ShakyWeights. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials, including written transcripts, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep 'em coupled.